Hi there, I'm Sean. It's Wednesday, as Alex told me earlier. Um, so, I'm sorry. Like it's all right. Yeah, tonight we're going to talk about Amazon S3. So my background, I'm a software engineer at Grubhub, but most of my career I've been doing platform engineering, largely working with Java, JVM languages. Previously, I worked for Twilio and Netflix and now Grubhub. Um, Mostly working on, right now, working on application frameworks and partnering with our data engineers to help enable an Iceberg project. So at the end of the day, you've got to persist some data to a cloud storage environment. S3 is what we use at Grubhub. AWS is our default environment. So I'm relatively new to the Iceberg. I only started learning about it maybe a year ago. I was in New York City and I attended a workshop from Alex at the Javits Center. And that's where I got a copy of the Iceberg book. And I'd encourage all of you, definitely download a copy of this PDF. It's definitely a good way to get started with Iceberg. So, so I like to think of it as like me, I'm a developer. I'm using cloud services, trying to figure out how to use AWS effectively. And having some working knowledge of S3 is really going to help move your projects forward for Iceberg. So, some of the background is that Iceberg was actually invented at Netflix. Netflix was, dealing with petabytes of data. They wanted ways to do schema evolution, and that was the work of Ryan Blue and Daniel Weeks. Much like Good Will Hunting, they were trying to solve a difficult problem, and this table format, was used internally at Netflix, and then eventually moved over to the Apache Foundation. So in the early days at Netflix, Netflix runs everything on AWS. And so the Netflix data engineers, they were really trying to figure out how can we use S3 as our storage engine for these petabytes of data. And so, with S3, you're organizing things into buckets. A bucket is sort of a container where you put all of your objects. And if you look at the Iceberg open source code, and you dig into GitHub and the Java library, you'll find that the Iceberg Java library has an abstraction called the file IO interface. And this file IO interface has multiple implementations. So, for example, if you want all your files written into S3, there's an implementation called the S3 file IO class, and that is doing the work. And that class is using the AWS SDK to connect to the S3 API. And if you go to GitHub, you'll find that S3 file IO is like the core class, but there's other supporting classes in there as well. So there's a concept in Iceberg called an input file and a concept called an output file. So you'll have, in the S3 world, you have S3 input files, S3 output files. So the Java library does all of this for you. You don't really need to read this code. Or if you use a managed solution like Dremio, you probably won't look at this code at all. But if you're like me, I'm like a very curious engineer. I like to learn kind kind of the lower level details of how Iceberg is reading and writing to the cloud. So this presentation, I've kind of truncated some of the content just in the interest of time, so we'll kind of move really fast through the rest here, but I'm just going to highlight some things that I think are interesting about S3, and just some things that I've kind of worked with along the way. So about 5 or 6 months ago, Amazon had their reInvent conference in Vegas, and they made some huge product announcements about the future of S3. And so there's these new capabilities in S3 that people can take advantage of. S3 tables is brand new, and S3 metadata. So what's really interesting is S3 tables demonstrates that AWS is truly committed to Iceberg. It's really a new way of doing native Iceberg in S3. And so the concept is that Amazon would like to be your fully managed provider of all your compute and data. And that's sort of what S3 tables is enabling, fully managed Iceberg tables. And when they announced this, they also announced a brand new bucket type. So when you're provisioning the new S3 bucket, if you want to use the S3 table features, you have to provision with bucket type known as table buckets. But what's really interesting is that these Iceberg tables, these S3 tables, are now first-class AWS resources. That means that you can have resource policies assigned to each Iceberg table. So if you're already doing all your policy management of all your AWS resources, this is just another way to manage those resources in the same way. Amazon also released some code at reInvent. This is a Java library called the S3 Tables Catalog. And if you take this Amazon library, combine it with the Java Iceberg library, it's a way to enable using basically the catalog metaphor and reading and writing to the S3 table buckets, essentially. So if you're in a company that's using Java, this is more or less how you add the project onto your application class path. And then beyond S3 tables, there's another feature called S3 metadata. And this is really interesting because in the S3 world, a lot of companies will need to track metadata about the objects that are stored in S3. So a lot of companies will spin up an instance of Postgres and then set up their own metadata tables and then manage the metadata over here in Postgres and then have all the objects over here in an S3 bucket. And Amazon realized that this was a common pattern that a lot of companies were doing. And what they realized was, it's just easier if they extend S3 to support metadata management. And so now with S3 metadata, there's now 21 default fields that are automatically tracked as metadata by Amazon. And then all of this metadata gets exposed as an Iceberg table by default. And Amazon calls this a system table, which means that you don't even need to create this Iceberg table. Amazon is managing it and populating it for you. So if you have a bunch of metadata that you're interested in about your S3 objects, now you've got an easy way to query all of your S3 objects. And so, the idea is let's make it really easy to query, just write some SQL queries. And that's kind of the holy grail of metadata tracking. And one of the features of this is it also allows you to set up your own custom tags for each object that you're storing in S3. So, you know, like if I had some objects that I was sourcing from somewhere, say like an IoT device, well, I could put a custom tag on that data when I'm writing it into S3, and then I can query these Iceberg tables and find out, you know, write custom queries to look at all those custom tags that I'm interested in. So the history of S3 is interesting. This was one of the earliest services at AWS. And in the early days, you know, the idea of S3 was that it was just for unstructured data. And in the early days, they just thought, well, people are going to want to serve static content from static websites. And so you just put a bunch of like HTML and JPEGs into an S3 bucket. But if you look at how this has evolved in the last 20 years, Amazon has realized that all of their customers were doing structured data in S3. And that's what Iceberg is. It's structured data in S3. So, you know, AWS has realized that, you know, the original use case of unstructured data is still important, but moving forward, they're really trying to innovate with structured data like Iceberg. So S3 itself just exposes a REST API. I'm kind of skipping through some of the concepts here, but as I said, there's this idea of buckets. A bucket is a container for your data, for your objects. And an object could be like a file, like a JSON file, or it could really be any sort of file that you have. So in terms of like how Iceberg is using S3, you know, Iceberg is storing data files, and Iceberg also has metadata files. And so, you know, those are just generic S3 objects at the end of the day. So when you're working with S3, if you're setting up a brand new application, you need to think about what kind of S3 bucket you want, and there's now 3 types. General purpose buckets, those are the original bucket types from like 20 years ago, and that's the most common bucket type. In fact, where I work at Grubhub, most of our buckets are just general purpose buckets. And Iceberg was really designed to work with, you know, general purpose buckets. But within the last 2 years, there have been these additional bucket types. Directory buckets are the bucket type that you would use with the S3 Express One Zone. I don't know if anyone's using S3 Express One Zone. If you're looking for low latency, high performance S3 storage, you would choose what's called One Zone, Express One Zone. And so you're trading off like durability guarantees, but you're getting lower latency. So if you had an application that was very performance sensitive, you would want to provision a directory bucket, basically. And then table buckets, as I said, is basically the new bucket type for Iceberg. Let's skip through some of this, but I think Alex mentioned this earlier. You know, with object storage, you need to think about the kind of storage type that you want, and S3 gives you lots of storage classes that you can choose from. There's kind of like the standard mode that's like the default for the most applications use. But where I work at Grubhub, we're using intelligent tiering. And intelligent tiering is a way to save money with your S3 data. And so with intelligent tiering, Amazon will keep track of like which files have you accessed in the last 30 days or 90 days. And once you get beyond that like threshold, they realize that you're probably not, if you haven't touched it in 90 days, you're probably not gonna, it's unlikely you're gonna use it again. So they kind of move it to a different, lower performing storage. And so you save money because they're kind of like moving your data to cheaper data for you, cheaper storage. And then Express Run Zone, again, that's the storage class for getting the higher performance. You do pay more to get the lower latency, but for some applications, that's what people need. I'm just going to skip through here. So if you're a Java programmer or Python programmer or down in the trenches, if you're writing an application where you're interacting with S3 directly, you just need to think about these primitives. You're either uploading data, downloading data, copying it, or moving it around, more or less. There's also a way to list objects in a bucket. This operation tends to be a little slow. And so they actually have made list objects to be, the response is actually pageable. So they don't, like if you had like a million objects, you wouldn't want a response that had all million of them in the response. But they do kind of give you a paginated list response. All right, so where I work, we're mostly a Java shop. We're currently using the SDK for Java V2. Although we do have some code in production that's running on the older SDK, V1, that is an end-of-life SDK. And actually, one of the things I'm trying to work on this year is converting some old S3 code to use the V2 SDK. But if you're using the Iceberg library, this is not really an issue. The Iceberg Java library is already on the V2 SDK, so not really a big deal there. So skip through that. And Amazon has done a lot of work in trying to optimize the way that applications interface with their cloud services. And in the last 2 years, Amazon has been promoting this concept called CRT. They published an open source library called this Common Runtime. And most of all the AWS SDKs are now using the Common Runtime. And it's sort of like this hyper-optimized way for your application to invoke the AWS cloud services. And so at least in the Iceberg Java library, there's now the CRT has been added in. Actually, if you download Iceberg 1.9.0, it now has CRT enabled by default for certain operations. So previous versions of the Iceberg Java library didn't take advantage of CRT, but future versions will take advantage of it. And they gave sort of a tech talk in Vegas about a couple of months ago, where they talked about if you have a performance-sensitive app and you're doing a lot of reading and writing to S3, you do get a significant improvement with CRT. Skip through some of this. Provisioning buckets. This is something that we think about at Grubhub. We try, as a platform engineering team, we want to enable other teams to do their own self-service and provision their own AWS resources. In our case, we're using Pulumi. Pulumi is sort of like Terraform in a sense. It gives you a way to encode the resources that you want to provision along the way. So this is an example of provisioning an S3 bucket as code with Pulumi. Another interesting topic about Iceberg applications is sometimes you want to run your code locally in a development environment. You don't want to have to deploy to the cloud and run in the cloud. And in the Java ecosystem, there's this thing called test containers that lets you run Docker containers locally. And so if you're running Iceberg, you want to have like an S3 storage engine running on your desktop. And I've tried these three different options. Local stack, sort of a way to emulate a lot of AWS services. Minio is just an S3 compatible storage engine. And then Adobe has this testing library called S3 Mock. And these all work pretty well. I've actually used all of them for testing Iceberg locally. I think Minio seems to have a lot of momentum for testing locally. And here's like an example. I wrote a little like test suite. I was trying to compare like Minio versus local stack just to see if they behaved equivalently. And in fact, they did, just for like basic puts and gets and things like that. So I'll skip through some of this, but anyway, there's some good videos on YouTube that I've watched, and I like to look back at some of the older videos just to see like where did Iceberg come from and what was the original intent. So back in June 2018, Ryan Blue was at Netflix and he gave this talk. It's on YouTube. And in the original form, Iceberg was just there to write data to S3. It didn't really work with other cloud storage solutions, but it's definitely evolved to do a whole lot more than S3 today. There's also this video from reInvent 2023. Netflix data platform engineers talked about how they were migrating legacy data into Iceberg. And so that has some good insights about how they were working at petabyte scale. And along the way, when you're working with Iceberg, you're going to inevitably, people talk about the small files problem, or table maintenance is another word for this. But Netflix actually built their own internal service called AutoTune, and they talk about it in one of these YouTube videos. But the future is that most companies don't want to like do this on their own. It's definitely better to have like a partner like Dremio or Amazon or other providers that will help tune your tables for you. And then a few months ago, I was had some free time, and I decided to rewrite part of the test suite in the Iceberg library, and I was able to get this merged. But so when the Iceberg Java library is being built, it has a test suite that runs, and that test suite doesn't connect to AWS. It just connects to Minio, and that Minio is just running on that test machine. And so I rewrote some of the code about how it was initializing Minio and setting it up, and then I purged some other old code that was in there. So now whenever there's a new Iceberg release, it's fully validated against Minio. So Minio is S3 compatible, so it's gives fairly high confidence that each release works with S3. I'm just going to skip through here, but if you're working with S3, and there's some interesting wrinkles about performance, and Amazon has some tech docs out there that talk about this, and they kind of warn you. They're like, well, once you've put your data in that bucket, like your baseline performance, you're going to get 5,500 GET requests per second, basically per prefix on your key. Um, and what happens is if you exceed that, you'll start getting an error message back from their cloud. So you'll be calling the S3 API, and you'll think everything's good, and then all of a sudden, they'll start returning you this error code 503, and it'll have a message in the response that says, please slow down, like you're overwhelming us. But what that means is that they weren't expecting you to send 1 million requests or what have you, and they are increasing capacity to catch up to the volume of traffic that you're sending. But 503 is basically like, hey, we haven't fully provisioned all the capacity, so like try again later, or please do an exponential back off, and hopefully it'll work the next time you try again. So you can see this. Now with S3 tables, they actually changed the request capacity. So like the general purpose buckets have the 5,500 requests, the GET request baseline. With the S3 tables, they made it 10 times higher. So it's actually 55,000 reads per second. That's sort of the minimum baseline for an S3 table bucket. We're just going to wrap up here. I'm going to say that there's this great video from KubeCon last November in Salt Lake City. The CTO of Docker talked about object storage in a more general concept. Because at Docker, they use a lot of object storage. They have a lot of things to store at Docker. Anyway, this talk was at KubeCon. It's really, really insightful. It talks about how they think about object storage at scale at Docker. There's also this video from reInvent, December 2024, what's new with S3. This is where they talk about the new capabilities that have come about in the last 12 months. And this slide is only here just to remind me that we're done. Thanks for indulging me with my crazy memes. Yeah, thanks. Follow me on Blue Sky these days. That's where I'm at. Thank you. Go ahead. Amazon publishes the S3 API spec as like a PDF file, and it's like 3,000 pages long. And yeah, there are a lot of cloud vendors that are now claiming to be fully compatible, but no one could possibly be fully compatible with a 3,000 page like API spec. I've looked at a number of other providers. I've looked at Cloudflare has their R2 storage. They support the S3 API. There's a company here in Boston called Wasabi. They are a storage platform. They do S3 support. There's also a company called Tigris. They're out in California. They were founded by Uber engineers. They are S3 compatible. But I don't think anyone is like perfectly compatible, and the API changes all the time. I did see that, like, I think Minio had an open source project that was like a test suite, and I think anyone could use their open source test suite to validate their own implementation. Um, but you know, like anything else, like I actually tested like 7 different S3 implementations with some tiny little test suite, and I found like little quirks. They weren't like significant, but um, yeah, fundamentally, the only big cloud vendor that's not doing S3 support is Microsoft. Microsoft did not want to support the Amazon API, but Google Cloud Storage does do S3. So, um, fundamentally, I don't think, I think compatibility is hard to do because the API is just a moving target. It's always changing. They're always adding things, and just have to constantly test, retest, and revalidate all the time. I think so. Yeah. Yeah, I've always wondered like the history of how they chose that particular slowdown message. Yeah. That was awesome.